Hello everyone, welcome back to Farouk Academy. I hope everyone is doing well today. So in today's lesson, we're going to create this awesome walkthrough screens, okay? So basically, that is the view that you have when you launch an app for the first time, okay? So today we are going to see how we can create this awesome design, okay? So we will learn how to create an onboarding screen in SwiftUI. By doing this, we learn a lot about interfacing with UIKit in SwiftUI. We will create our onboarding screen by implementing an UI view controller, okay, with feeding it with SwiftUI views. By doing this, we will learn how to integrate UI view controllers into SwiftUI and how to transform SwiftUI views into UI view controllers, okay? So to get started, you're going to launch your Xcode, okay? And create a new Xcode project called onboarding screen, for instance, okay? So here you're going to select single view app, then click next. Here we said onboarding screen, en, okay? After creating the project, import the images, okay, into your assets folder, okay? It's like that. Drag and drop. Okay, so let's create a new file, okay? Here select Swift UI view and click on next. Here name it subview and then click on create subview, just like that, okay? As said, we want to dynamically display different images when initializing this view later on, okay? So let's declare a variable image string for this purpose, okay? So here var image string to be type of string, okay? It's like that. Cool. Next, insert an image object with pathing the image string variable, okay? So here image, okay, image string, it's like that. We're going to write resizable, aspect ratio will be fill, and then we're going to clip it to the view, okay? Cool. So to properly frame the image, we have added those modifiers, okay? So now we need to update our preview structure for showing a sample image. So here you can write image string and here first, for instance, okay, just like that. Then press on resume. Okay, this is how your subview should look like now, okay? So that's all. Theoretically, we could now use this view for creating our subviews, but as said, we can't directly use SwiftUI views for feeding a UI page view controller, okay? Instead, we first need to transform them into UI view controllers. So first, we have to create our onboarding view, especially for holding our UI page view controller. To do this, create a new SwiftUI file named onboarding view, okay? So here, onboarding view, like that, okay? So as mentioned before, the onboarding view will be the place to embed our UI page view controller in. So because of this, it's also the right place to initialize our subviews for passing them to the UI page view controller. Okay, so let's create an array for storing our subviews. So here, var subviews is equal to okay, because our UI page view controller will only accept UI view controllers, we have to transform our subviews into UI view controllers. Okay, we can simply do that by declaring an UI hosting controller for every subview respectively. Okay, UI hosting controllers are used for wrapping SwiftUI views in order to use them within the UIKit framework. Okay, so here the first one will be UI hosting controller. Okay, this one, and then here subview, this one first. Okay, we can copy paste this line 3 times. Just like that. Okay, so here it's gonna be second, okay, third, and fourth. Okay, cool. So at this point you can delete the default content view Swift file since we won't need it anymore. So here, this one, delete, move to trash. Okay, but then we have to set our onboarding view as the root view when the app launches. Okay, we do this within the scene function, okay, inside the send delegate file here. So we're going to change it by writing onboarding view, okay, just like that. Great, we successfully prepared our subviews for feeding our UI page view controller, which we will create now. Okay, so we just learned how to convert SwiftUI views into UI view controllers using an UI hosting controller. But how can we embed a view controller of the UIKit framework, like a page view controller is one, into our SwiftUI onboarding view? Okay, so first of all, let's create a Swift file called page view controller. Okay, so here, Swift file, this one this time. Okay, you're going to call it page view controller. Okay, make sure you import the Swift UI and UIKit framework. So here, Swift UI and then UIKit frameworks. Okay, then create a structure called page view controller. So struct page view controller, just like that. Okay, we want to work with our subviews in this file, therefore declare an appropriate array for holding them, which will get filled with the UI hosting controllers when initializing the page view controller inside the onboarding view. Okay, so here you can write var view controllers to be type of UI view controller, just like that. Okay, in this file we will create our UI page view controller for embedding it into the onboarding view. For being able to do that, we must conform it to the UI view controller representable protocol. Okay, so here UI view controller representable. Cool. So the UI view controller representable has 3 mandatory methods. The first one is make UI view controller. This method is used for creating the UI view controller we want to present. Then update UI view controller. This method updates the UI view controller to the latest configuration every time it gets called. And finally, make coordinator. This method initializes a coordinator which serves as a kind of a servant for handling delegate and data source patterns and user inputs. Okay, we will talk about this in more detail later. So let's start by creating our UI page view controller by using the make UI view controller method. Okay, so here make UI view controller, okay, just like that. So here you can add page and just remove the word some. Okay, we don't need it because we want to return a UI page view controller. We have to indicate this behind the arrow like that. Okay, so let's create the UI page view controller and return it. So let page view controller is equal to UI page view controller. This one, okay. So the transition style is scroll, okay. Navigation orientation is horizontal, and we don't need that, okay. Then we can simply return the page view controller, just like that, okay. The update UI view controller will get called every time the UI page view controller gets updated. For example, when the number of content views of it are changing. Because we use a static number of view controllers for our page view controller, this function will only get called once, namely when the UI page view controller is being rendered first. Okay, so when this happens, we have to configure our page view controller with setting the first view controller of the view controllers array to display first. We do this by using the set view controller method. So here update UI view controller, okay. Here you are going to change it by page view controller, okay. Now it's good, the error is gone, okay. Set view controllers, okay. So here we are going to write view controllers. The first element is 0, okay. The direction will be forward, animated true, and we don't need the completion block, okay. Cool. So at this point, our page view controller is ready to be embedded. We can now insert it into our onboarding view by passing our subviews. Let's also add a frame to it, okay. So here we can change it by writing page view controller, okay, subviews with a frame just like that, okay. I can delete this line, and normally the error is gone now, okay. If I go back to onboarding view and clean the project, normally we are good to go. Okay, so as I was saying before, you notice that we are currently not able to sweep back and forth. This is because we didn't yet implement a data source pattern for telling our page view controller what subview to display when the user swipes back or forth. Okay, let's change this by implementing a coordinator. A coordinator is implemented by creating a subclass inside the page view controller, which we can then use for implementing the common data source functions we need for telling our page view controller which subview to display when the user swipes. The coordinator is set up by inserting a coordinator subclass into the page view controller with having a parent variable, okay, and a init function which we need for initializing the coordinator in our page view controller, okay. So here class will be coordinator to be type of NS object. Here we're going to write var parent to be type of page view controller, okay, and here init page view controller to be type of page view controller, just like that. And self dot parent is equal to page view controller. Okay, so we can now initialize the coordinator by calling the make coordinator method of the UI view controller representable protocol. Okay, so here func make coordinator, okay, and here coordinator self, just like that. Okay, so as said, we can use our coordinator for implementing common Cocoa patterns like delegates, data source, and responding to user input. We want our coordinator to act as the data source for our UI page view controller. So let's conform the coordinator subclass to the UI page view controller data source protocol. Okay, so here you are going to write UI page view controller data source. Okay, so this protocol requires one function for returning the right view controller after the currently displayed view controller in our view controllers array, and one for returning the right view controller before the currently displayed view controller of our view controllers array. Okay, so let's add the view controller before and view controller after methods for telling our page view controller which view controller of the view controllers array to display when the user swipes. Okay, so here for the moment we can close that. Okay, so view controller before, okay, and view controller after. Okay, cool. So now we can write god let index is equal to parent dot view controllers dot first index of view controller, okay, else return nil. Okay, then if index is equal to 0, return parent view controllers dot last. Okay, and finally return parent view controllers index -1, just like that. Okay, so if you prefer, I can add some commentary. Okay, okay, cool. We can do the same with the second function. Okay, so here we are going to write god let index to be equal of parent dot view controllers dot first index of view controller, okay, else return nil if index +1 is equal to parent dot view controllers dot count, return parent view controllers dot first, it's like that, and finally return parent view controllers index +1. Okay, so just like before, I'm going to put some comment. Okay, it's like that. So since our coordinator subclass now conforms to the UI page view controller data source protocol, we can assign it as the data source of our page view controllers inside our make view controller method. Here we can write page view controller dot data source is equal to context dot coordinator. Okay, it's like that. Great. Now every time the coordinator's view controller after and view controller before method gets called and tells the page view controller to display previous or next view controller, we can check it that works by running our app in live method and swiping. Okay, so here, cool, very nice. Okay, great. We just learned how to use a UI page view controller in SwiftUI. Beside that, we also learned how to feed this controller with SwiftUI views by using UI hosting controllers. Now we will finish our app onboarding by adding the text, setting up the dotted page indicator, and implementing a button which the user can use for going to the next view of the page view controller. Okay, so to update the page view controller, when we click on the next button, which we will implement in a moment, we need to keep track of which page of the page view controller should be currently displayed. To do this, let's create a state property, okay, here, which serves as the source of truth, which lets us know that the page view controller should get updated according to the value of this state. Okay, so let's insert a current page index state inside the onboarding view. Okay, state for current page index is equal to 0. Okay, depending on this state, the text objects and the page view controller should get updated. Okay, we'll see how to accomplish this in a moment, but first let's implement a button for changing the state's value when the user taps on it. So wrap the page view controller instance inside the onboarding view into a vstack and insert a button object. Okay, here vstack just like that. Okay, and then button okay, just like that. The button should contain a white arrow with a black round background. Okay, so here image system name, okay, arrow dot right. Okay, here resizable, here foreground color will be white, the frame .30 or by 30. Okay, with some padding. The background will be color dot black. Okay, and corner radius will be 30, just like that. Okay, if you want, you can outsource the button's content as an external view like this. Okay, so I'm going to create it manually. So struct your button content to be type of view. Okay, then cut that, put it right here. okay, and simply right here button content. Cool. Okay, so I also have to write var body to be some view, and now it should work. Okay, and then right here it's like that. Cool. As said before, the current page index state needs to be updated when the user taps the button. Therefore, let's write an action that adds 1 to the state's value, but be aware that we want to display the first page again when the user reached the last page and taps the button. We can take it into account by writing a suitable if-else statement. Okay, so here, this one, okay, so here if self dot current page index plus 1 is equal to self dot subviews dot count, then self dot current page index is equal to 0. Okay, otherwise self dot current page index plus equal 1, just like that. Okay, we can delete that. Cool. To see if this works properly, let's also insert a temporary text object for showing the current value of current page index. Okay, so here text currently shown page current page index, just like that. Okay, we can now try out this functionality by running a live preview. Okay, but instead of this temporary text, we want to display 2 text blocks for displaying information depending on the currently shown subview. So let's insert 2 arrays, one for the titles and one for the caption. So in my concern, I have simply copied the 2 arrays. I'll let you the time to copy them. Okay, you can put the video on pause and copy, on stop and copy these 2 arrays. Okay, next insert 2 text objects into your onboarding view, each of it displaying a string of the arrays subscript by the current page index value. Okay, here the first one, text. Okay, titles. Okay, current page index. Okay, font will be title. Okay, then text captions. Okay, with the same current page index. Okay, we're going to give it some modifiers. So the first one is subheadline. Okay, then the foreground color will be gray. Okay, the frame will be this one. Okay, so 300 by 50, and the alignment will be leading. Okay, just like that. And the line limit is nil. Okay, cool. So now our preview should now look as follows. We can now delete this text. We don't need it anymore. Okay, cool. So if you want, you can run the app again and see if the text gets updated properly when you tap the button. Okay, so binding the page view controller to the current page index state means that when the state gets updated, the page view controller gets updated too, and that when the binding gets updated, the state gets updated. Doing this is pretty straightforward. Just insert a binding property named current page index into the page view controller. So here, binding var current page index, just like that. Okay, so since we can now refer to the current page index, we can update the update UI view controller function. Okay, so here we can select it through here, so this one, for showing the subview depending on the current page index state's value, which we've set to an initial value of 0. Okay, so here current page index, just like that. Okay, now we have to update the initialization of the page view controller inside the onboarding view with binding it to the current page index state of the onboarding view. Okay, so here we are going to write current page index. Okay, and here subviews again. Okay, so let's run our app again. I'm going to clean the project. Okay, stop. Now every time we tap the next button, the state gets updated, which also updates the current page index binding. Okay, what that happens is that the page view controller gets updated, which triggers the update UI view controller function and eventually shows the next subview. Okay, but now try to swipe. You notice that the text don't get updated. That's because we've not yet told the page view controller to update the current page index when the user swipes. Let's change this. Okay, so updating the current page index can be done with a delegate pattern. Okay, so here UI page view controller delegate. Okay, so the appropriate method to use is the did finish animating function. Since okay, now we can go there and write did finishing. Okay, this one. Okay, if completed, let visible view controller is equal to page view controller dot view controllers first. Okay, let index is equal to parent dot view controllers dot first index, okay, of visible view controller, okay, then parent current page index is equal to index. Okay, just like that. The method gets called when the swiping of the user is finished. When that's the case, we then grab the shown subview and locate its position inside the view controller's array. Depending on that value, we can then update the current page index binding, which then also updates the current page index states of the onboarding view. Okay, Let's assign the coordinator as the page view controller's delegate inside the make UI view controller function. So here is equal to context dot coordinator. Okay, let's run our app again and see if that works. Okay, so great. Every time we swipe, the current page indexed state of the onboarding view gets updated through the updated binding property of the page view controller, which eventually updates the text objects of our onboarding view accordingly. Okay, so last but not least, we want to have a dotted indicator. Okay, how many pages the page view controller has and which one is currently being displayed. Okay, such an indicator is part of the UIKit framework and called UI page control, which is an UI view. Create a new Swift file called page control. Okay, so here page control, like that, and make sure the UIKit and SwiftUI frameworks are imported. Import UIKit and import SwiftUI. Okay, then create a structure called page control and conform it to the UI view representable protocol. So struct page control to be type of UI view representable. Okay, our page control needs to know how many pages the page view controller has. It also needs to know which page is currently being displayed. So let's create a property number of pages and create a binding to the current page index state of the onboarding view. So here, for number of pages, okay, it's like that, and binding var current page index. Similar to the UI view controller representable protocol, the UI view representable protocol has two mandatory functions which need to be implemented: the make UI view and the update UI view function. To make the make UI view function is used for initializing the UI view for the first time. Obviously, the update UI view function gets called every time the UI view gets updated. Okay, let's start with creating the make UI view function. Okay, make sure you indicate to return an UI page control object after the arrow. So here, UI page control. Okay, inside this function we create an UI page control. So let control, like that. We set the number of dots by using the built-in number of pages property and assigning it to the number of pages property we declared above. We then modify the color of the page control and return it. Okay, so control dot number of pages is equal to number of pages. Control dot current page indicator tint color will be UI color dot red. Okay, and control dot page indicator tint color is equal to UI color dot black. Okay, then return control. We then implement the update UI view function. Okay, every time the current page index state of the onboarding view gets updated, the current page index binding of the page control gets 2. This then triggers the update UI view function. So let's use this function to tell the page control which dot of the page control should be highlighted when the user goes to another page. Okay, UI view, this one, dot current page is equal to current page index. Okay, so now we just need to initialize a page control instance inside our onboarding view with passing the number of pages and binding it to the current page index state. So here we can write page control, okay, number of pages, okay, subviews dot count, and here current page index. Okay, this is a great opportunity for reordering the elements of our UI view and adding some paddings to make it look more nicely. Here group, like that. Okay, here give it some padding. Okay, then an add stack. Okay, first cut this line. Okay, then add a spacer and then add okay, give it some padding as well. Okay, and I think we are good to go normally. Okay, so let's run our app and try everything out. Okay, so here I'm going to clean the folder and now relaunch our app. Okay, cool, very nice. As you can see, it works perfectly. Okay, so that's it. We've successfully created our own onboarding screen in SwiftUI. We learned a lot about interfacing with UIKit and experienced the great power of this synergy. Okay, we learned how to implement UI view controllers and UI views into SwiftUI views, and saw how to embed SwiftUI views into UIKit objects. Okay, so thank you very much for having followed this tutorial. I hope you enjoyed it. Give it a thumbs up. Don't forget to subscribe and don't hesitate to share this content and eventually do this exercise many times in order to understand every part of this lesson. Okay, so that's all for today, guys. I see you in the next lesson. Take care. Bye-bye.